One of the most important strategies for students to know is the combinations that equal 10. It is a foundational fact from which students can derive many facts. How many more to equal 10? If you have 6, how many more to equal 10? 4. Adding on to 10 is not an official basic fact, but in preparation for making 10 strategies, students must know combinations of 10 and 10 plus another fact to equal more than 10. All of the basic facts with sums greater than 11 and 18 can be solved by using making 10 strategy. Students use their known facts that equal 10 and then add the rest of the number onto 10. To solve 6 plus 8, a student might start with the larger number 8. See that 8 is 2 away from 10, therefore take 2 away from 6 to make 10 and then add the remaining 4 to get 14. And using 5 as an anchor, 7 plus 6, the student breaks 7 down to 5 plus 2 and 6, 5 plus 1. 5 plus 5 makes 10, and then 11, 12, 13. Near doubles are also called doubles plus 1 or doubles minus 1 facts and include all combinations where one addend is one more or one less than the other. The strategy is to double the smaller number and add 1 or to double the larger and subtract 1. Therefore, students must know their doubles before they can work on this strategy. Subtraction facts prove to be more difficult than addition, perhaps because it receives less attention and because it requires knowing the related addition facts. In the think addition strategy, students use known addition facts to produce the unknown quantity or part of the subtraction. For 13 minus 8, a student thinks what plus 8 equals 13. One way to build a relationship between addition and subtraction is to use the triangle or T cards. Both cards help students see the relationship between addition and subtraction because, for example, you would have a triangle with 8, 5 as the base and 13 as the tip. 8 plus 5 is 13. You can say 13 minus 8 equals 5. 13 minus 5 is 8. Story problems that promote think addition are those that sound like addition but have a missing addend: join, initial apart, unknown, join, change, unknown, and part whole and part unknown. The down under 10 is the reverse of making 10, and there are two ways to think about it: separate and comparison. In the problem 14 minus 8, for separate you are taking away 8, so jump down 4 to get 10. Then jump down 4 and the answer is 6. For comparison, you are finding the difference or distance. How far apart are 14 and 8? A good place to begin multiplication facts is 2's, 5's, and 10's. These facts connect to students' experiences with skip counting and addition doubles. Facts that have 2 as a factor are equivalent to the addition doubles and should already be known by students. 2 times 7 is the same as 7 plus 7. 5's. Practice skip counting by 5's. Keep track of how many 5's have been counted. If we jump by 5's 4 times on a number line, where will we land? Use arrays that have rows with 5 dots. 6 times 5 is 6 rows with 5 in each row. Zeros and ones. 6 plus 0 stays the same, but 6 times 0 is always 0. Or that 1 plus n is the next counting number, but 1 times n stays the same. 9's can actually be derived from 10's. For example, 7 times 9 can be found by finding 7 times 10 and removing one set of 7. 70 minus 7. Facts. Focus on the minute hand of a clock. When it points to a number, how many minutes after the hour is it? Connect this idea to multiplication facts with 5. Hold up the clock fact card and then point to the number on the clock corresponding to the other factor. In this way, the 5 fact becomes the clock fact. 9 facts have interesting patterns that can help you find the products. The tens digit of the product is 1 less than the non-9 factor. Also, the sum of the two digits in the product equal 9. 7 times 9 equals 63. A tens digit is 1 less than 7. 6 plus 3 is 9. Using your hands to solve factors of 9. Hold up both hands, start with the pinky on the left hand and count over for which fact you are doing. For example, 4 times 9, you would count, move to the fourth finger, bend it down, look at your fingers. You have 3 to the left of the folding finger, so 3 tens, and 6 to the right, 36. For subtracting a group. This strategy can generate many other facts. For example, all three facts can be thought of as times 2 and 1 more. All 6 facts can be thought of times 5 and 1 more. Doubling applies times 2 foundation facts and is a very effective reasoning strategy in helping students learn the difficult facts. Games are fun to play over and over again and therefore are an excellent way to provide repeated experiences for students to learn their facts. Playing games that infuse reasoning strategies help students be able to be flexible, select different strategies, and decide which strategy is most appropriate for the given problem, and become more efficient and accurate in finding the answer. Games also increase student involvement, encourage student-to-student interaction, and improve communication, all of which are related to improving academic achievement. Games can help students learn and practice reasoning strategies. As you use games, remember to focus on related clusters of facts and on what individual students need to practice. Also encourage students to talk about their strategies and to self-monitor, work towards using effective strategies. To self-monitor, students should be able to identify their toughies and continue to work on reasoning strategies to help them derive those facts. Focus on self-improvement. For example, students keep track of which strategies they use as they go through their fast facts, and then 2 days later pull out the same stack and see whether they are quicker. Facts over time. Rather than do a unit on memorization, work on facts over months and months. Involve families, send games homes, ask family members to help students by using reasoning strategies when they don't know a fact. Make fact practice enjoyable. Make them non-competitive so people do not have anxiety. Technology gives immediate feedback and reinforcements and helps them to self-monitor. Emphasize the importance of knowing their facts. Without trying to create pressure or anxiety, emphasize to students that in real life and in the rest of their mathematics career, they will be recalling these facts all the time. Little insight is gained from timed tests. They can potentially negatively affect students. Think about how the student on step 3 feels compared to a student on step 8, 9, or 10. It's great to celebrate student success, but avoid comparisons between students. Work on foundational facts first, then move to tougher facts. Don't work on all facts at once. Select a strategy and then work on automaticity for the set of facts. Be sure they are really learned before moving on. Work on facts over time, months, and months, not just one unit. Mathematics is about reasoning, using patterns, and making sense of things. Mathematics is problem solving. Requiring that students master the basic facts before they can use a calculator has no foundation. Calculators should be based on the instructional goals of the day. Students that do not recognize inverse relationships use triangle and T cards. Students that not apply the commutative property addition use a 10 frames for each add-in and reverse them. Add context that can be reversed. Multiplication apply the adding or subtracting or a group students lose track of the group size. Provide examples of the problem using an array. Show how the known fact is used to add or subtract a row.